Hi guys, this is Vineet and I welcome you to this video. Today's video topic is index disk space calculation in SQL Server. So we will talk about how disk space for indexing gets calculated in SQL Server. Before we proceed ahead, I would request you guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button, it will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding my future and upcoming videos. The reason I'm asking you to subscribe is because I don't want you to miss on any of the videos that I will be creating on indexing these days. And I think there are almost like 15 to 20 videos which are still pending to be released. I think you should be subscribed to my channel so that you can get timely notifications for the videos I post regarding indexing, so that there should not be any gap in your learning. So please go ahead and subscribe right away. There's a subscribe button below this video. Click on that subscribe button and follow the process. I'm waiting guys, please go ahead and do so right away. So guys, I hope you must have subscribed to my channel by now. So let's move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our videos as well, so please do share in your comments and suggestions. You can share your stories as well. We eagerly wait for your comments and suggestions, and we do love to read them, so do post in your comments and suggestions guys. We have created some playlists for you to watch. Some of the common SQL Server playlists are SQL Server database design, tables, business continuity, indexing, performance tuning, integration services, and transact SQL. And if we talk about this video pertains to the SQL Server indexing category. And if we talk about the total number of videos posted on our channel, we have posted around 245 videos at present. Soon we are reaching the 250 mark. Channel page link is given at the bottom of this slide. And guys, link for all these playlists and my channel page link is also given in the description area of this video. So please check out my video description area. You will get all the links. Now let's come back to today's topic, and today we are discussing how the index disk space calculation is done in SQL Server. So let me take you to notes directly. So today's topic is index disk space calculation. Now whenever an index is created, rebuilt or dropped, all these three operations, creation, rebuilding of index, and the drop operation on the index, disk space is required for both the old source and the new target structure. So at the time of creation, rebuilding, and drop operation, we need disk space for both the old structures as well as the new structures. And this disk space is required in their appropriate files and file groups. The reason we need the disk space for old structure is because the old structure is not deallocated until the index creation transaction commits. So until the index creation transaction commits or completes, the old structure is not deallocated. And by old structure, I mean the old index structure, which we are rebuilding. Now, also additional temporary disk space is also required for any sorting operation. This may also be needed. Now, in this video, we will discuss about how the disk space requirements to create a cluster index is determined. So here we are showing you an example. Basically, we are taking an example of cluster index creation, and we will show you how you can calculate the disk space requirement for this cluster index. Now we are assuming some of the conditions before creating the cluster index. So we are taking an existing table, which is a heap on which the cluster index is not present, and this table contains 1 million rows, which is 10 lakh rows. So this table contains 1 million rows, and each row has a size of 200 bytes. So each row is 200 bytes long. So this is the first assumption. Second assumption is this table has a non-cluster index A, and it's a non-cluster index, and it is also created on 1 million rows. So it is not a filtered index, so it is created on all the rows, all the 1 million rows. And for index, the row size is 50 bytes long. For this index structure, index A, for non-cluster index, each row is of size 50 bytes. Now there is also another non-cluster index B created on this table on the 1 million rows itself, and each row of this index is of 80 bytes long. So there is a difference in the size of the row of each index. So for index A, each row size is 50 bytes, and for index B, each row size is 80 bytes long. Now fourth assumption we are taking is that index create memory option is currently set to 2 MB. Later on we will show you how to find out this option. But yeah, initially we are taking this consideration that index create memory option is set to 2 MB at present. And also the fifth assumption we are taking is that fill factor value of 80 is being used for all the existing and the new indexes. And what do we mean by the fill factor of 80? By fill factor of 80, we mean that the pages will get only 80% full. They will not get 100% full. So that is the meaning of fill factor. It basically denotes the pages fill factor. Now, as a result of creating the cluster index, two non-cluster index must be rebuilt. So whenever we create a cluster index on a table, and if there are existing non-cluster indexes present on this table, those non-cluster indexes will also get rebuilt in case we create a cluster index on that table. And the reason for rebuilding of these non-cluster indexes is basically there is a row indicator which need to be replaced with the new cluster index key. Alright, so earlier the row indicator was different other than the cluster index key because the cluster index was not present on the table. So the two non-cluster indexes were using the different row indicator apart from the cluster index key. Now whenever we create the cluster index on that table, the two non-cluster index will also get recreated and to basically replace the row indicator with the new cluster index key. Now let's dive into the example how the disk space calculation is done when we create the cluster index on the table. And first of all, we are talking about the disk space calculation for an offline index operation. So during the offline index operation, the index is not available, or if it is a cluster index, the table is also not available. That is basically the offline mode in which the underlying table is not available whenever we are rebuilding the index. Now in the following steps, both the temporary disk space that is to be used during the index operation. So during the index operation, we need the temporary disk space for any sorting operations. Alright, and so we need a temporary disk space as well as the permanent disk space to store new indexes, and we are calculating both the temporary disk space as well as the permanent disk space in this example, and we will show you how this space is being calculated. And the calculations shown here are approximate, they are not exact, but we will give you the approximate idea how this is calculated, and the tilde is used to indicate the approximate calculations. So whatever calculations we are doing here are the approximate calculation. So let's talk about creating a cluster index on as a offline index operation. So let's see how we can determine the size. So until the new structure gets created or until the index creation transaction gets committed, old structures stay in place. We just read that, right? So the disk space must be required for the source structure. So let's see how to determine the size of the source structure, because it will be present till the index operation is going on, index building operation is going on. So first of all, we have a heap which has 1 million rows. So heap is a table without the cluster index, so it has 1 million rows. And earlier we were talking that each row is 200 bytes in size. So if we multiply 1 million by 200 bytes, so it comes down to approximately 200 MB. So for the heap we need 200 MB of disk space. And for non-cluster index A structure, how much disk space do we need? So index A is already created on the 1 million rows. So let's take 1 million rows. And each row was 50 bytes long. So earlier we had taken these approximations. So we have made an assumption that each row of this index A is 50 bytes long, and for index B it's 80 bytes long. So let's see how the size for the non-cluster index A is calculated. So we will multiply 1 million rows with the 50 bytes, and for indexes we can take a fill factor, but for table we cannot take a fill factor. So for here We are multiplying 1 million rows with 50 bytes and dividing the result by 80%, which is the fill factor. And this calculation comes down to 63 MB. Similarly, for index B, the calculation is coming out to 100 MB, and we have 80 byte row size here in comparison to 50 bytes. So if we talk about the total disk space required for source structure is these three items, the heap, the non-cluster index A, and the non-cluster index B. So the total size is 200 plus 63 plus 100. So it comes down to 363 MB. So the size required for the store structure is around 363 MB. Now we need to determine the size for the target structure because the target index will get created. So let's talk about determining the size of the target index structure. Now we are assuming here that the new cluster index key is 24 bytes long. And this key is also including a unifier. We'll talk about unifier later, but for now let's assume that this new cluster index key is 24 bytes. The row indicator 8 byte long in both the non-cluster indexes will be replaced by this clustered key. So earlier the non-cluster indexes were using the row indicator, which was 8 bytes in size, and this 8 byte in size row indicator will be replaced by a 24 byte indicator, which is a cluster index key. It will be replaced by a 24 byte cluster index key. In both the non-cluster indexes will be replaced by this clustered key. Now let's see how the disk space calculation is being done for the target index structure. So let's calculate the size of the cluster index. So let's calculate the size of the cluster index. It will be created on 1 million rows, which have a size of 200 bytes, right? And for index we can use the fill factor, but for heaps we cannot use the fill factor, right? So we are taking a fill factor 80 here. That was the assumption. We are taking a fill factor of 80. So this calculation comes down to 1 million into 200 bytes divided by 80%, which is the fill factor, and it comes down to 250 MB. Let's calculate the size for the non-cluster index A. Now we will multiply the 1 million rows, and here the row indicator will get replaced, so we need to calculate for that as well. So the size of the row for this index is 50 bytes. So we will deduct 8 bytes for the old row indicator and add the 24 bytes for the new indicator. So this is the calculation: 50 minus 8 plus 24 bytes and divided by 80%, which is the fill factor, and this calculation comes down to 83 MB. And for non-cluster index B, we are multiplying 1 million rows. Each row is 80 byte in size, and we are removing the size for the old row indicator and adding the new size for the cluster index key, which is 24 bytes, and we are dividing it by the fill factor of 80%, and it comes down to 120 MB. So if we together or collectively take the size for the target structure, it is the cluster index plus the non-cluster index A plus the size of non-cluster index B. So it comes down to 250 MB plus 83 MB plus 120 MB, and this total size of the new structure comes down to 453 MB. So 250 plus 83 plus 120 come down to 453 MB. Now if we talk about the total disk space required to support both the source and target structures for the duration of the index operation. So we are talking about the duration of the index operation when the index operation is going on. So how much space is required during that time. So we need the space for the source structure as well as we need the space for the target structure. So it comes down to 363 MB plus 453 MB, right? So total disk space required to support both the source and target structures for the duration of the index operation is 816 MB, which is 363 MB plus 453 MB. The calculations were done here previously. And the space currently allocated to the source structure, so the space which is currently allocated to the source index structure will be deallocated once the index operation is complete or committed. So we don't need 363 MB later once the index operation is complete, but till the time index building operation is going on, we do need this 363 MB of additional disk space as well to support the source index structure. Now third disk space required is the temporary disk space for any sorting operations. So let's see how do we calculate that. So under that, two options comes up for calculating any temporary disk space. So it depends upon whether we are using the sort in tempdb option or not. So space requirements are shown for sorting in tempdb, and we are using both. We are taking both the options. With sort in tempdb set to on, first we will calculate using that, and sorting in the target location, which is sort in tempdb set to off. So if the sort in tempdb is set to off, the sorting is done in the target location itself. So we do not need any additional temporary disk space if we are if the sort in tempdb is set to off, which is the default option. And if it is set to on, we do need additional disk space in the tempdb for the sorting operation. Now let's take the A option, which when the sort in tempdb is set to on. Then in those scenarios, tempdb must have sufficient disk space to hold the target index structure or the target index, because sorting is taking place on the target index. So this sorting will happen in the tempdb. So it must have sufficient space to hold the target index. So let's see how this space is calculated. So the target index structure will have 1 million rows, and each row is of size 200 bytes, so it comes down to 200 MB. And basically we do not consider any fill factor in the sorting operations. Now additional disk space in the tempdb location. So earlier we were talking about the option where we are taking this index create memory option is set to 2 MB, so we need to add that as well. So we are taking additional disk space in the tempdb location, which is equivalent to the setting configure the index create memory server configuration option. This setting can be configured. We will show you later when we create video on this topic. And this we are taking the assumption that it is set to 2 MB. So 200 bytes plus 2 MB. So the total size of temporary disk space required with the sort in tempdb option set to on is 200 plus this 2 MB, so which comes down to 202 MB. Now when the sort in tempdb option is set to off, which is the default option, the 250 MB of disk space already considered for the index in step 2 is used for sorting. So when this option is set to off, so earlier we calculated the size for the target structure. So target structure size was this, the cluster index size was this 250 MB. So this is the option 2. I don't know why it got changed to 1. Alright, so the disk space required for cluster index is 250 MB in the target location. So if the sort in tempdb option is set to off, this 250 MB in the target location for the cluster index will be used to perform the sorting operation as well. So when the sort in tempdb is set to off, the 250 MB of disk space already considered for index in step 2 is used for sorting. So we do not need additional space for sorting if this option is set to off. The target index structure for the cluster index, whatever space is required for that, is also used for the sorting operation. So any additional space is not required in tempdb if the sort in tempdb option is set to off. Now additional disk space is required 2 MB, which we talked about earlier. Index create memory server configuration option 2 MB disk space. So this additional disk space is also required. So the total temporary disk space with the sort in tempdb set to off required is 2 MB only, because the target structure will support the sorting operation, and target disk space is also already considered, right? So the only disk space we required is for this particular option, which is 2 MB when the sort in tempdb is set to off. Now if we talk about the using tempdb, which means using the sort in tempdb option set to on, a total of 1018 MB is required, so which comes down to this 202 MB with the sort in tempdb set to on. So 200 plus 2, 202 MB, and we are adding this to the total space required, which was 363 plus 453, which came down to 816 MB. So 816 MB plus 202 MB calculated here, which is a temporary disk space, and earlier the 816 MB disk space is for source and target index structures. If we combine that disk space and with using the tempdb, or sort int MDB set to 1. A total of 1018 MB is required, which is 816 plus 202. This space would be needed to create a clustered and non-clustered indexes. Alright, so whenever we create cluster indexes, non-cluster indexes will also get created. So total of 1018 MB of disk space is required. Although using tempdb or sort int tempdb option set to 1 increases the amount of temporary disk space required used to create an index. So if we use this option sort int tempdb set to 1, this requires additional temporary disk space for the sorting operation, which can be used to create the index. So this increases on the disk space requirement, but it will reduce the time that is required to create the index when the tempdb is on a different set of disk other than the user databases. So it does provide some performance benefits if we are using the sort int tempdb option, and if our temporary database is stored on another disk apart from the disk where the user databases are stored. Now if we are not using the tempdb option or sort int tempdb set to off, a total of only 818 MB is required, so which is 816 plus 2 MB, and this much would be needed to create the clustered and non-clustered indexes. So guys, this is how the calculation is done using the offline index operation, and we have shown you calculations by both using the sort int tempdb option and without the sort int tempdb option. Now let's talk about how do we calculate disk space for an online cluster index operation. So in the online cluster index operation, the index remains visible, or the table will also remain visible or accessible to the user when we are performing the, or whenever we are performing the rebuild, drop or create index operation. The table will be accessible during that time if we are performing the operation in the online mode. Now whenever you create, drop or rebuild a cluster index online, additional disk space is also required to build and maintain a temporary mapping index. So if we are using an online cluster index operation, we need additional disk space to build and maintain a temporary mapping index. So this is the additional structure. For this additional structure, the mapping index, some additional disk space is required. And what is this mapping index? This temporary mapping index contains one record for each row in the table, and the contents of this mapping index are union of the old and new bookmark columns. So this is the contents of this mapping structure. And to calculate the disk space needed for online cluster index operation, follow the steps for the offline index operation. So whatever steps we followed for the offline index operations, those are required, and we can add the disk space which is required to support this additional temporary mapping index structure. So to calculate the disk space needed for online cluster index operation, follow the steps for an offline index operation and add those results to the result of the following steps. So what is that following step? We determine the space for the temporary mapping index. That's the only additional step is in the online mode, and we need to determine the space for this temporary mapping index. Now in this example, the old bookmark row ID of the heap, which was 8 bytes, and the new bookmark is the clustering key, which is 24 bytes including the unifier. This new mapping structure contains the old bookmark as well as the new bookmark. So old bookmark is the row ID of the heap, which is 8 bytes in size, and the new bookmark is the clustering key, which is 24 bytes long, and this includes any unifier. And there are no overlapping columns between the old and new bookmarks, so there are no overlapping columns. And let's see how the temporary mapping index size is calculated. So it's created on the 1 million rows, and we multiply it with, there are two columns which are maintained. One is 8 bytes in size, another one is 24 bytes in size. Total comes down to 32 bytes, and we multiply with this with 1 million rows, and we are taking a fill factor of 80%. So this comes down to 40 MB in calculation. So we add this 40 MB to whatever previous calculations we have done for indexes for the offline mode. We can add this value to that calculation. Now the disk space, this disk space requirement for a mapping structure must be added to the required disk space in the target location if sort int tempdb is set to off. So if the sort int tempdb option is set to off, this disk space is required to the target location space requirements, and this disk space is also added to the tempdb if the sorted tempdb option is set to on. Now let me summarize this. So we have created a table for you for the disk space calculations. So first operation is we are performing an offline index operation with the sort in tempdb option set to on. So the total disk space that is required during the operation. So we are talking about the total disk space required whenever the index operation is going on. It is not yet completed. So the total disk space required is 118 MB. The breakup of the disk space is we need the disk space for existing structures and the target structures. So for any existing tables and indexes, 363 MB is required. And as we are using the sort in tempdb option, in tempdb we need 202 MB of disk space. We had shown you the calculations earlier. So for existing table structures, we need 363 MB. For tempdb, we need 202 MB. For any new index structures, we need 453 MB. And the total of these comes down to 1018 MB, which is the disk space required with the sort and tempdb option set to on. Now once the index operation is complete, we do not need the disk space required for any source structures, so we can remove this disk space. So the target disk space is 1018 minus 363. So 453 MB is only required, and we also do not need the disk space in the tempdb once the index operation is done. So the only disk space required after the index operation complete is the 453 MB, which is the size of the target index structure. Now let's take the another option. We are offline doing an offline index operation with sort and tempdb option set to off. So the temporary disk space in tempdb is now not required. So we can omit that option. So the total disk space that is required during this index rebuild operation when the sort and tempdb is set to off is 816 MB. Now let me show you the breakup of this. So we need any disk space during the operation for any source structures, which is 363 MB. And for new indexes, we need 453 MB. We do not need any temporary disk space in the tempdb database, so that can be omitted. And this particular disk space can be used, the disk space which we have taken for the new indexes, the same disk space can be used for any sorting operations. So we add 453 to 363, and this comes down to 816 MB, which is required during the index rebuilding operations. And when your index operation is completed or index transaction is committed, we do not need the disk space for existing source structures. Only the new index disk space is required. So after the operation is complete, the index rebuilding operation is complete, the total space required after the operation is only the space required for the target structure, which is 453 MB. Now let's take another example where we are building the online index operation with sort and tempdb set to on. So with the sort and tempdb set to on, we need additional disk space in the tempdb equivalent to the size of target cluster index, and we also need any additional disk space for holding the mapping structure, temporary mapping structure. So the total disk space during the which is required during the operation index rebuilding operation is 1058 MB. Let me give you the breakup of this 1058 MB. So we do need during the index rebuilding operation, we do need disk space for any existing tables and index structures, which is 363 MB. And in addition, we are using the sort in tempdb option, and therefore we need additional disk space in tempdb, which is equivalent to the size of the target cluster index. And now this will also include any mapping index as well. So the total comes down to 242 MB. Now we also need the disk space for creating any new index structure, which was 453 MB. So this total comes down for all three options come down to 1058 MB, which is the total disk space required during the index rebuilding operations. And once the operation is complete, we do not need the space for existing tables and structure, and we do not need any tempdb disk space, and we do not need any space for the temporary mapping index. So these two items can be omitted, and we only need, after the operation, we only need 453 MB of disk space, which is the space required to hold the new index structure. Now let me discuss the fourth option, which is we are doing the online index operation. So we need the space for the additional temporary mapping structure, and this time we are taking sort and tempdb option to off, so we don't need additional disk space for in the tempdb for any sorting operation. So the total disk space required during the index rebuilding operation is 856 MB. The breakdown is we need disk space for any existing source tables and indexes, which is 363 MB, and we need the temporary mapping index disk space, which is 40 MB, and we do not require any tempdb disk space, so only 40 MB is required for temporary mapping index, and for new indexes we need 453 MB. The total of these three items comes down to 856 MB. So this is the total amount of disk space that is required during the index rebuilding operation, and once the operation is complete we do not need any space for the existing source structures, and we do not need any temporary mapping index disk space. The only disk space required after the operation complete is the disk space to hold the new index structure, which is 453 MB. So the total space required after the operation is 453 MB. So guys, this is how the calculation is done. Let's discuss the next point. This example we have discussed above does not consider any additional temporary disk space. So if we are doing any online index operation, there is also any additional temporary disk space required for storing the version records which are required for the online index rebuild operation, and these version records get created by concurrent user updates and delete operations. So we need additional temporary disk space for that as well, but we have not considered that disk space while doing the above calculation. So you need to keep this in mind. For this item as well, we need additional disk space, and this additional item is to store any version records created by concurrent user activity, which is the update and delete operations triggered by the users during the online index rebuild operations. The user can access the table, so they can perform any updates and deletes against the table as well. So we need a mechanism to store the version records, and for that we do need the additional disk space. But here in the calculations we have not considered that, but yeah, you should consider that as well while doing an online index rebuild operations. So guys, we are done with this video. I hope you like the content of this video. Today we have discussed how you can perform the index disk space calculation or approximate index disk space calculation, and we have shown you the topic where we have discussed how disk space calculation for an offline index operation is performed, and we have also discussed on how the disk space calculations for any online cluster index operation is being performed. And finally we have discussed this table, giving you the breakup of how much disk space is required under each of the operations with different options set to on or off, especially the sort in tempdb and the online index rebuild operation or not. So guys, I hope you like the content of this video. If you really like the content of this video, please do hit on the like button, which is coming below this video. Also guys, if you are new to this channel or if you are an old user who have not yet subscribed to the channel, I would highly recommend please go ahead and immediately subscribe to this channel, because I don't want you to miss on any of the videos, especially the indexing videos that I will be creating in the upcoming 15 to 20 days. So there is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming and future videos. So guys, don't miss out on that, otherwise you will miss out on notifications that will get generated as soon as I post videos on my channel. So if you don't want to miss those notifications, please go ahead and subscribe right away. So there is a subscribe button below this video. Click on that subscribe button and follow the process. I am waiting guys for 5 seconds. Please go ahead and do that right away. So guys, I hope you must have subscribed by now. Also guys, please do share your comments and suggestions, your feedbacks. We eagerly wait for your comments, and we do love to read the same. So do post in your comments and suggestions guys. And also guys, if you have good network of friends, please do share my videos with them via the share button that come below each of the videos. You can share my videos through that share button over any of the social media platforms with your friends. And guys, you can also ask your friends to subscribe to my channel in case you feel my videos or my channel can make difference in their life, and if they are also working in SQL Server domain. Do share my videos with them, and also ask your friends to subscribe to my channel. I need this help from your end. So I thank you so much for your time on this video today guys, and you have a wonderful day ahead guys. Thank you.